So introducing myself, I'm Michael Bachelor. I have had a number of hats. I would introduce myself as an Industry 4.0 solution architect or industrial digital transformation architect. There's a lot of buzzwords you can use. I have nearly 30 years of experience in control systems integration, manufacturing execution systems, automating the processes in plant floors. And so I focus on aligning digital strategies that improve industrial operations reliability. Performance may be a word you want to use. That's where my focus is. And safety, flow, money, all those things matter. The city of Sabetha, Kansas, it's where I live. I was a customer in a sense, a vendor, not a vendor, a partner customer, so to speak, to begin with this, and I'm very happily integrated in with the team, having found this. It's my hometown, and finding an answer for it. And Sabetha implemented an EdgeLake project to modernize its utility management systems and reduce risk. The project, orchestrated by AnyLog with a little integration assist, aimed to address challenges with aging technology. Furthermore, we have an aging workforce. Experienced resources were retired, taking plant knowledge with them. So I'm going to walk you through the decision and implementation process that we went through. So why did the city implement the EdgeLake solution? To begin with, we had a catastrophic failure. Fortunately, we didn't have a catastrophe, but aging technology failed. In particular, a switch failed. A human machine interface screen at the plant did not indicate that, and just stayed stagnant. And a younger or a less experienced workforce wasn't as familiar with checking things and cycling through. So it was a perfect storm that led to the clear well going dry, which is what supplies water to the town. If there would have been a fire, the firemen would not have had any water coming from the hydrant. So it categorizes as a catastrophic failure. That's not a common thing, but it certainly triggered this as a need to stay more on top of our infrastructure. And so that and the aging technology drove this. That knowledge loss that comes from retired resources had a whole lot to do with that as well, as I had mentioned. So we have that we need to work with and give an assist. And then there are further operational risks or costs, I should say, that aren't as high as a clear well going dry, but they still matter. And one such case is wastewater has blowers, and they'll work more often as you have more influent coming in, and less often as you have less. Where the sensor is located to sense it can be fooled, and so they're struggling with the physical location, whether they can change it. But in a downpour, you're running constant because it thinks it has to, and that can wear out a $30,000 to $40,000 blower. So that in and of itself is a value add to the budget to look at it as well. What were the city's required objectives for this solution? I'm going to back up here just a little bit, and I told you what triggered it. Let me talk about the infrastructure, not the technology infrastructure, but the city. The city's a small town. It's 2,500 people, and it has a water plant. And not every town produces its own power. We do. So we have a power plant, and we have a wastewater plant and a water plant. And those three plants, they're the utility production to the city. There's also lift stations around town, and there's other components that we could go get. But right now, the only focus for us is the power plant, the water plant, and the wastewater plant, monitoring it and helping people stay alerted to attention they need to give it. It may not be maintenance, it just may be the process. But whether it's the process they need to pay attention to or something that needs fixed, either way, we want to keep it monitored. And we want that to be reliable and accessible. So the accessibility of the legacy is you have to be sitting at the plant to see the screen, or there is a secondary location at the dispatch so that we can have some redundancy and somebody there 24/7 you could call and ask to look at something. But that's not the same thing as having an operator whose attention is on it and training is on it. So at the time they had to sit at the plant to see anything going on. We would like to be that mobile, not just around town and other parts of the city, but invariably Murphy will be calling up when somebody goes on vacation. If they can look at something and give an answer over the phone, that's a lot better than where they are or where they were. So the reduced costs, I mentioned already, it's related to finding places similar to the blower example where you can get on something more quickly to keep the maintenance from becoming costly. And so you have the uptime first, but you have the budget management second. And being a small town, this is something that certainly scales as much as you want. But we needed it to be a practical investment to get started. We're a small town with a small town budget. There are certainly means to do things the right way. However, it's definitely not a blank check. Government most of the time won't be, but a small town is thinking more practical with their budget. So that needed to come into play. And they didn't want to do that with an idea they would rip and replace in the future. They want a future life cycle management strategy that is sustainable, that doesn't have to be ripped and replaced when you have an improvement you want to make. They want a foundation to build on for continuous improvement. The legacy system was really simple. There was nothing there besides the Fairbanks Morse generators in the power plant to begin with, and they had real-time trends. They just wanted to be able to look at a little bit of history. That was it. So we have the traditional PC install model that we were following. That's the way you did it. And you had all the maintenance that goes with that, the Windows operating system support and upgrades and licensing of the software. So it was the traditional thick install, more labor, and we just used an in-touch screen and logged data to it for historical trends for 30 days. That was that. And things expanded from there with that same system. After the catastrophic failure, we took the cloud native platform approach. Not to go into too many details, but that was a struggle for multiple reasons. There's some complexities. You do have to be, and to just speak to a controls engineer's life for a moment, there's a lot of skill and advancement there in a controls engineer. Their head is in the plant, the design, the schematics, the logic narrative, the PLC programming, all of those skills. A number of them will want to go into data architecture, software architectures, but it's a low number percentage-wise. Most don't do that. And so you'll have a smaller crowd that has the skill sets to go full stack, cloud stack engineering and design and architect a solution. And you do have some skills there. And many want to, but that is a thing. Then the second one is costs, and that might actually be something I should have put first. Ingress is it's bait to get you in. It looks very cost effective. So I'm sure you've seen that. Egress, I'm sure you've seen where that's gotten some people in big trouble. That's a different matter. In industry, egress is going to have to be a thing. There isn't one monolithic system to talk to. Whether you have ERP, MES, inventory, logistics, whatever, you're going to have probable needs for egress. And then cloud data services can certainly rack up, especially when you get to AI. That's a cost model that people don't necessarily know how to solve yet. So we tried to use a platform that was going to handle the cloud native for us, that wasn't really, for various reasons, mature and ready, and we struggled with that for over a year, and it just wasn't going anywhere with the provider we were talking to. So I needed an answer for the city, that I promised them something here, and there was a need to pivot. And fortunately, I was introduced at a time prior to when I had to pull the plug to Moish, and I got to learn more about what's going on with EdgeLake, and okay, this is the path. The local processing is one of the reasons it's the path. Control and operational technology people, we don't control things from the cloud. We want information in the cloud, maybe, but we don't control things from the cloud. We're very comfortable on the edge anyway, as long as it's manageable, low cost, low maintenance solution that doesn't require traditional IT oversight constantly. This is a solution that sounded good as well. And so we changed directions in the towards using the EdgeLake for this solution. We had industrial PCs on each site at this point. We happened to use Lenovo SE30s. You could pick a number of them, and it was sufficient for our needs, even though we were thinking cloud native. AnyLog is lightweight. It could sit on a very small computing device. It just depends on what your data load needs are. So in that setup, by comparison to the struggles we had before, when it was time to set up and configure the system, we're using Postgres for the data storage of the data itself that EdgeLake sits on top of, and is the metadata management of. This is an hours to do thing in many cases. It could be days depending on what your architecture is. That's a duration as compared to your more traditional project. When it's time to ingest the data into the data lake, it's also an hours to days effort. And we use a tool called Dynix Fusion. That's a topic for another time, and that can be flexible, but how you ingest that data into the data lake is how AnyLog will build your schema for you. You're not having to have SQL skills with Postgres or another database option that you could use, a number of them. So that builds your schema for you, that ingests the data into the data lake, and that's a kind of a low code, no code advantage. And then building the queries to pull the data out so that you can visualize it, integrate with it. That's the same. That was quicker in our case. That was hours, and we build queries within AnyLog in a query node. I'll show you the architecture here in a bit. And that's not SQL language either. That's kind of the low code part. It's more of a common delimited list of elements that you want that have been contextualized between the disparate edge nodes, brought together as if one database, one data lake. And that's an hours to set up event. And then we used Grafana. We downloaded a version we put on a container that's free. We didn't need the services. So Grafana is a no cost container on the edge as well, and connected with the queries using JSON. Most of the time there was just designing the screens we want. And then I'm going to say it was a couple of days fitting in to different spots during a week, and that got that done. So that's the effort level we're talking about to invest in, and the stand-up time that you'd be looking at for this kind of a system. And it's not a linear scale on how long it takes if it grows. It's going to be more time for a larger system, but I wouldn't say it's linear. It scales very well, very efficiently. Taking a look at the architecture here kind of a high-level view, we're talking to ControlLogic's PLCs at each plant. So that's an Rockwell Allen Bradley ControlLogics. We mentioned we have SE30 industrial PCs, Lenovo SE30s. That's where we install both the Dynix container, which we happen to be using to talk to the PLCs. You could use OPC UA directly from within AnyLog as well. And then we have the AnyLog node, and that's the operator node for AnyLog. That's where it will, in this case, Dynix, ingest the data into AnyLog. It will have, based on how you decided to model that, it will build your schema and store into PostgreSQL, in the case of the city of Sabetha, sitting on that industrial PC. It does that for each of the water plant, the wastewater plant, and the power plant. And these do not know about each other, at least not at this level. In addition to that, there is a query node that brings that together as one data lake, one contextualized set of data in an ontology. Now, using that word, it is a unified ontology. This is not for those that are ISA 95 aware, it isn't exactly that, but it is a contextualized ontology, as if one database in one data lake. So the decentralized part is the nodes on a decentralized physical infrastructure on the edge, and those advantages. But the centralized part is the data lake and the data coming together as if it's one database to the query node to pull those queries in that manner. The lake is really managed as one lake by a master node. In this case, this can be blockchained together without the master node. That's going to be a choice, and it depends on how you want to do it. Some plants will not want a peer-to-peer, perhaps maybe just for IT policy, and they are okay with a pipe between them and a centralized node that they're controlling somewhere. So you follow that rule, and this can manage that. But that's a choice, master node or blockchain. Either way, it's the same data lake. And then we apply high availability operator nodes as well, so that the metadata is everywhere. The data itself stays with the edge. Now, to that point, I want to point out there's no cloud contract here. There's no cloud data services here. And those are the things that you got to watch out for maintenance and cost. But when you stay with the edge, we didn't want just one node that's holding the information for the water plant, for instance, and the same with the other two. We wanted to have high availability of that data, so we wanted to replicate that. And we have done that with on separate nodes, water, wastewater, and power. They each have the second node logging. That can expand as much as you want and where you want to put it. Grafana is also a container that I'd mentioned, and we built that talks to the query node with JSON, and that is the access that the user gains. That's where they gain access to the information. That's the only place. If you're going to get on site remotely, that's going to be IT and the right controls engineers from the controls company that can do that. Certainly the people in that maintain it, but for anybody who's not an outside user or even authorized within that group, there's no remote access. We're not doing secure remote access down to here. We're only accessing the Grafana dashboard, read only. It has its security, and then we're managing the back end behind that connects to the plants without any intervention of a human. So this is the only way in. and there's different layers depending on what you need, your appetite and need for investment is. There's a lot of layers of security here that are available. The key benefits, well, all appropriate city personnel can access the data and trust it without being at the facilities, and it's simple to use. We simplified the navigation compared to the old HMI screens that we used as a poor man's dashboard. So it is simple to use, available to everybody at any location they have a device they can access with. And it does, I say it mitigates risk and costs. It does, because if you have the water operator that's not at the water plant, they can have their attention on it. Your lesser experienced personnel, there are also people that have been in the city a long time and have seen a lot of things and maintained a lot of things. They may not be the water plant person, but they may be the electrical foreman, maintenance tech of some sort, and the administrator. They have some experience where it's good for them to see it as well in order to contact the right person to get the job done. And it's, you know, really basic but helpful. And again, this is the foundation to build further value than that on top of. Some planned events that we have, initiatives we're looking into. IBM Open Horizon, just kind of give a little plug there. We're going to IBM Tech Exchange to talk about this because it fits into that whole infrastructure path forward with what's called containerization. Docker container would be a reference, and living on an environment that's a decentralized infrastructure network that has a Linux operating system environment that is native to containers. You need to manage it. This is a small example, but when 3 sites and a handful of containers turn into the number of nodes for AnyLog become hundreds or thousands or tens of thousands and beyond, now you need a way to manage it. And Open Horizon is an open source tool and partnered with LF Edge that it helps you deploy, manage, and secure those applications that you can push down to the edge so that you're not having as much. That's part of why it's less IT infrastructure support, and why it can be. That's integrated ready with EdgeLake, and we want to bring it to Sabetha. Using EdgeLake rule engine for real-time alerts, it's ready to go. And the city's been slow at wanting alerts. They don't want nuisance alarms. That's an industrial, problem in general. But we have a rules engine for real-time alerts, ready to integrate and send the right person the email or the text message. We're kind of waiting on them for that. PDF report writer. One of the things about industry, manufacturing, or utility, there's always something to report, or at least there has been. That's more of a relational data batch report. Could be ingredient, chemicals at the water or wastewater plant. It's the daily or weekly or monthly power usage that you report to the state. There's relational, column and row reports that typically are needed. So we don't just want to stream in the data like time series only and then put it on a dashboard. We have to have that printed report capacity. And there is a built-in PDF report writer, Ori's waiting on me to get him the right information. We work together to give the city a report that replaces an old one, going back to Crystal Reports days. So we got to have a means of going in and helping replace legacy reports as well when we go into the plant. And then we're looking at workflow management and training, a training platform, a knowledge base for training, as well as capturing the fixes that we do. Actionable information system is on the docket. That also relates to unstructured data. So when you're architecting, and there's a term called industrial data ops, I used it earlier. It has enterprise data in mind, but for industry, you're going to have time series data, whether you're replacing a chart recorder or a OSI Pi historian or whatever the case is. You have time series, you'll have relational data. What about video? What about CAD drawings? What about documents that are written for instruction? Where's your document and video and unstructured data management? That's something to consider, and there's a platform for that. AnyLog is able to integrate into MongoDB for NoSQL storage for that as well. You can have more than one database for more than one purpose, and there's a way to architect that. And this is all a part of ongoing continuous improvement. AIS, just try to be brief here and not read the whole screen. You want to have your digital information give you you'll have a severity factor in what you're monitoring. Hopefully it's not reactive, but at least it can get you on track. If it is, hopefully it's planned or predictive. You're pulling in all the media that makes sense, that gives you information to help you make a decision. It could be a document that's related to how something works, a video that relates to how something works, a diagram, remote whiteboarding together, that sort of thing, as well as past incidents, past maintenance. Might not have been an incident, it may be just planned maintenance, and something happened. You logged it in the knowledge base, and it in context knows that you might want to look at this and help you. And it's that kind of idea. This is more of the same, but in the sense of I mentioned the video. This is an example where you have a viewable video in Buffer that's a snippet that fits the time frame of a window when something happened that you want to see, if it's relevant. That could be something that is brought in context. If you have a digital twin, and that is a goal, whether it is in the city of Sabetha or not yet, I don't know. I would like it to be. That's going a little future, but you could bring that in and collaborate, not just go look at the digital twin, but here are specific things we want to look at in it. That's the direction we want to get into to help out training lesser experienced people, assisting them, reference for experienced people, collaboration to find, fix, and finish things faster, to solve things that are risks or makes costs that are occurring zero in. Additional future objectives. We're pretty close to done here. Federated learning. That's where you can use the edge infrastructure with the EdgeLake data lake, and you can use that as the data lake of data that AI uses and run it on the edge instead of in the cloud. And that's desired in many cases. It also is cost effective in comparison, and maybe immensely cost effective. I don't have the exact records, but AI might be struggling to find a viable business case currently, and this is one of the reasons is infrastructure. I think finding a deliberate thing that you're needing to do and that actually adds value, the same reason you would hire a person, we're getting there's an innovation every hour, it seems. And it's magically doing things for us. Well, it's not magically doing things for us. The ones that are defining that what's needed better are getting help. But there's a cost structure here that I think is going to make AI more valuable. I think federated learning is how that's going to happen. And this is a platform for it. And a couple of examples with machine learning and agentic AI. I haven't explored the depths of this, but it'd be nice to have a help desk person that's pleasant 24/7 that you can call and has a knowledge base to reference in how to help you or steer you to the right direction. Those are pretty ready right now, as well as a data scientist that has the advantages of analytics that it can see, watching, could be temperature, pressure, vibration, amps being pulled, that you have a bit of a predictive plan for when something might happen, and then you can see specific analytics that say, all right, you need to pull maintenance and change the lube on this particular motor. And then it's accountability as well to see that it was done. Digital twin, I mentioned earlier, we would like to apply a digital twin and replace, and what EdgeLake helps you do is replace complex integration. It's more plug and play approach. There is, and I'm going to give a slight brief little plug. I'm going to take Moishe's lead on this. Brief little plug. We're not going through this. I just want to point it out so that people can go see it for themselves if they want to. There's a partner with EdgeLake that has integrated EdgeLake into their digital twin, and they talk about the architecture setup difference and how it's simplified. About the 2-minute 48-second mark, I think, of this 4-minute video, if you go to the AnyLog site on YouTube and you look up Wineo Smart Buildings 4 minutes in the video list, it'll be the 4-minute one. Go up to about the 2:48 mark, and you'll get a brief explanation from them as why this was architecturally more simple to set up, and that can be of use for you. That concludes my presentation today, and I am ready to turn it over to questions, comments, and so forth.
I have a couple of questions. This is John Reynolds. Just a couple of things. On the description there, you went through the approach towards the high availability arrangements with having multiple nodes as far as logging and things like that. Could you take just a moment and describe when you say high availability, what did you use for that?
Okay.
In terms of failover and that sort of thing.
Right. So I wouldn't say that there's a failover so much as they're included in the data lake with everything else. That sort of failover factor just is handled for me. I would defer to, because Ori set it up, I would defer to Ori for if it gets into the weeds of the technical explanation, but it's additional nodes on the data lake, and it's just redundant in this case rather than something new. These are virtual machines that have Linux on them and install in the same way that on a more robust infrastructure for reliability purposes, that is the same as the node on site, and it's simply that log in that operator nodes log in that same data from, let's say, the water plant, just in lockstep, so to speak, with the industrial PC. So it's redundant logging, and I'm just going to say a little semi-ignorant the way that the EdgeLake handles that for you.
John, I could
Please do.
A few things about the internals there. So the way Michael set it up is that you've got a PLC and it brings the data to the Lenovo node. It's using a connector called Dynex, but that's the detail. It's not doesn't make a difference, but eventually the data reaches the Lenovo node, and it is streamed there and ingested by a database. This database is replicated. It's part of the AnyLog network. So when data comes in, it's organized as log files. And this log file, so let's say log file represents the last few seconds of data. These last few seconds of data are replicated to as many nodes that you want. So think about it as physically the data goes from the PLC to a node, to a physical node, but logically think about it as you connect the PLC to a cluster of nodes, that each one of those maintains a copy of the data. So in Michael's setup, there are two nodes. One is on site and one is in some remote location. And so every data that is streamed in is now being serviced in two places. The query process would go to one of those nodes. Usually it would go to the node that is on site. But if this node fails or is not reachable, it would reach out to the second node and pull the result set from the second node. This whole synchronization of replicating the data in multiple nodes is done transparently under the hood, part of the query protocol. At the end of the day, you end up with very much like the cloud, right? Even in the cloud, if you work with a database, there are replicas of the data. You've got different places that hold copy of the data. It's the same model here. When you push data to a database, it's replicated to as many nodes that you want. In Michael's case, 2 nodes. And the query process is such that if it's not able to reach to a node, it would go to a node that has a replica of the data and service the query from there. Next to it, there is a process that says, okay, if a node fails, there is obviously it misses the data, right? It has a lag in the data. The query protocol is such that when the node comes up again, it's able to identify the data that is missing and make sure that the data reaches there. So it would ask the data from a surviving replica. So if a node fails and then comes back again, then there is a process that would sync the data between the nodes, and all of that is transparent, is part of the query protocol.
Got it. Just one more question for you, and I realize by the scope of what you're doing, this is the configuration is probably well known. But as you retrieve the information from the various devices out there through, I believe you said through the Dynex connector, is there any translation or anything like that of the data that comes in specifically for the configuration data, so that you have kind of a model that you're working against, or do you just use the data that is in the messages that are coming in?
It's a short. There are multiple ways in AnyLog when the data reaches there to add your logic. So you could say, I'm interested just in those values, or unify values, or add additional information that is not in the source data. So there is a setup. There is a service that allows you to manipulate the data to the way you want it to be.
Got it.
I would also say that, Michael alluded to schema being automatically created. So depending upon the source of data, we'll automatically create schema based on data source. For example, OPCUA. We'll look at the tag structure of that, and the schema gets created based upon the tag structure that gets imported through OPCUA. In Sabetha's case, exactly what happens is they're using a Rockwell protocol, which has a similar tagging structure as OPCUA. So that is how the schema gets automatically created based upon the import of that source.
And so that's OPCUA. There's different ways to go about doing this. In Dynex, we can control the message flow, and so you could set it up so that you're treating it more like time series logging. You can set it up so it's more of a relational database for a batch report. There's some flexibility there on how you would log it. I want to ask a question to make sure that we're answering your question. So that we've talked a lot about, okay, you're connected to PLC, you're messaging with something like a Dynex, you're pulling that in and creating your schema and storing it in Postgres. Then we're pulling that data lake together. And in that data lake, there is a contextualization of data. When you say model, I kind of want to make sure I understand what you mean. Do you mean structure like ISA 95? Do you mean unified namespace by chance? I want to make sure we're answering the question.
But it's just a matter of the identification of where the messages are coming from.
Oh,
is in the message, but then using tags or other arrangements, you come to additional information as far as what is this device? I mean, what are we talking to out here? And for reporting purposes and things like that, sometimes a different nomenclature as far as what the device is all about is easier to manage.
Yeah,
right.
that's an interesting point, because one of again, when you're pulling data from a PLC, let's say, you don't have a lot of information about what that PLC is controlling or what process that PLC is part of. All you're getting is the raw values from the registers on the PLC. So one of the things that EdgeLake does is it provides, as part of that metadata that Michael referred to, it provides the ability to add metadata to any device that's got time series data flowing in. So you could add things like, this is part of process A as a tag. This is part of process B as a tag. This is location A. This is machine B. So you could add that metadata to the tag. And then when AnyLog or EdgeLake pulls that data in, that metadata gets applied to it, so you can query it, even though the raw machine data does not have it. Does that make sense?
It sure does. It sure does. I just wondered what the philosophy was. That's very clear.
Yeah.
Okay.
And it is a little. There's a little work to do to make that definition. Not necessarily time, but that's where you may. And this is. I'm not speaking to unified namespace. I want to make sure that that's not. I'm not saying we built that, but in designing it, you might architect it like an ISA 95 diagram with, enterprise, site area line unit, that type of thing. You could define it that way, at least knowing where you're getting something, and then you define your nomenclature for your tags, for instance, in that. So that gives you the ability to name things and in that sort of a manner, and so that you are your magic decoder ring, so that you can do that. And a unified namespace wouldn't be a bad idea to add to this as well, but that's not something we've done. I don't have MES and EAM and WMS and ERP all integrated where that frictionless data integration is needed. So we haven't needed to add a UNS, but it's sort of contextualized like an ISA 95 UNS, if you want it to. It's sort of like that.
I want to add something, John. I think one of the things that EdgeLake brings is, if you're familiar with OSIsoft, now it's in Schneider Pi, which everybody's using. We actually had a demo on that yesterday. So Pi is two. If you look at the Pi system, it has two parts. One is the historian that keeps track of all the historical data, which is equivalent to the Postgres data that we maintain. But the other side of it, it's called AF, Asset Framework, which is basically the metadata. It keeps all the relationships and all the logic. And AnyLog has a really strong, or EdgeLake has a really strong approach here, where all the logic is represented as policies that are saved on a blockchain, or what we call a master node if you don't want a public blockchain. And you are there able to represent all the logic that you want. It's organized as policies, and you have full control of it. And what is reflected to the user is really the merger between the historian, the data that is being streamed in, and the metadata. And you have full control of it. So you could manipulate how the data is presented. You could use those policies and this metadata to impact data that is before it even hits the database. You have full control using those two components and this layer of policies that allows you to determine what you want to do or how you want to think of the data. By the way, those policies that I mentioned, this metadata goes beyond just representing the data. It goes all the way. So today, when we deploy an EdgeLake instance, we even don't mess around with configuration files. It's all policies represented in the blockchain. And you could say, well, let's bring up a node at some location and assign it configuration number 7, and that's it. You don't even have to log to the machine or log to the node and put any configuration there. You could think about it as a single place of truth that lets you control everything from how the data should be represented all the way to how deployment should look like.
Got it. Thank you very much. This is very nice.